Okay, so we're now doing, do you like the unicorn? We're now doing the second half of 2.4. So part 2, we're going to focus on stretches. So it's the same idea as the stuff I did in the last video, but just this time focusing on what actually is the first step. And that would be compression and expansion, which I sort of talked about in the last video, where referring back to a parabola, because you know about it already, compressing it this way or making it narrow versus expanding it out this way would be an example of what I'm talking about with stretches. It changes the shape of a graph to make it wide or narrow. That's the part we just talked about. And the first one would be called vertical expansion. I'm abbreviating all of them just to make it quicker because we're going to be talking about this a lot. So if I had something like y equals f of x, and instead I made it y equals a f of x, if the a value is bigger than 1, then it's an expansion by a factor of a. And I feel like this stuff isn't really going to make sense until you get to the point where we're actually doing examples. I just wanted to refer to it in terms of variables because you might get questions that are set up in this way, so it's helpful to know this. But don't worry if you're a little unclear right now. Once I actually put in numbers and we work our way through examples, I think you'll find it's a lot easier to make sense of it. So the next one is vertical compression. So if we have y equals f of x, notice how the a is still there in the same spot as with the vertical expansion, but this time the a would be in between 0 and 1. So it would be a fraction instead of a whole number like in the last example. And that would be a compression by a factor of whatever a is. So let's dive into actual examples because I think that's the part that's going to help to make this make sense. If we start off with something like y equals 2f of x, this would be a vertical expansion by 2. The 2 that's out front. I'm going to get you into the habit of still asking yourself that same initial first question, which is, does this 2 affect the x values or the y values? And the answer would be the y values because it's in front of the whole thing, f of x. So that's how I know that it's a vertical expansion. So that's a good habit to get into. Notice how here I have a factor of a third here. So this would actually be a vertical compression by a factor of a third. So again, this is affecting the y values. So what that's saying is it's taking your graph and sort of doing this to it and shrinking it down. Let's take a look at what this would look like on a graph. I'm going to remind you of stuff that I believe you probably already know. This is missing the middle. Whoops, I gotta fix this in black. And just put the axes there, pretend it went right through the, okay, that's not good. Let's go right through the middle. So we'll have that and that and that and that. And if this is a regular parabola, y equals x squared, maybe last year or maybe not, you've talked about this pattern of 1, 4, 9. This tells you the pattern of the y values. So these are the y values for when x is 1, 2, and 3. This is just a really quick way, like if you have this pattern in your mind, 1, 4, 9, then when you have to do expansions or compressions or any of that stuff, it's going to make it much quicker and easier for you to work with that because you already have this basic function or this basic set of y values to refer back to. I feel like I'm talking really fast. If you need to, I'll try to slow down. But the nice thing about the online video, and I say this every video, is that you are able to pause at any point. You can rewind and go back to any of the examples. So it's giving you some freedom and flexibility for what pace you go at. So if I'm going too fast, then just pause it, go through it yourself, and then come back to it when you're ready. So if I have this value of 149, and let's say instead I want to show a graph that has, let me do it in color. So let me say I'm going to do y equals 2x squared. So you think to yourself, does this 2 affect the x values or the y values? And then the next question is this going to be wider or narrow compared to my original? And because it's a 2, it's saying that you're doubling the y value. So it's actually going to be narrow. And I know that that might appear confusing because when you look at it, you might think like, oh, it's double, so it's going to be thicker. It's the other way around. It's doubling the y values. That's important to notice. So basically, how we had this 1, 4, 9 pattern, this 2 is doubling these values. So do you see that it would actually be 2, 8, and this is going to be 18 instead? So although I didn't really even draw y values, but basically so that you can start to get a sense of what's happening, where I would have my x value of 1, think of it this way. If you plugged in a 1 here for your x value, you would get 1 squared, which is 1 times 2. So you'd get double the y value. So you'd be up here, let's say. And if you did that for 2, same thing. So what ends up happening is this narrow little parabola in here. That's what a 2x squared parabola is going to look like. Whoops, maybe I should say that's a vertical expansion by 2. And then similarly, if I do y equals a half x squared, well, I kind of already told you, if this one's narrow, this one's obviously going to be wide. And that's because what this is saying is you're halving your y value. So instead of 149, it's going to be half, or maybe decimals is easier, I don't know, 0.5, that's going to be 2, and that's going to be 4.5. So what that means is at 1, instead of going all the way up to 1, I'm only going to be at half the value. And I can go on, but you can see that it's going to end up doing this. And I've drawn them all on the same grid so that you can see the comparison, even though they're not the neatest looking things, but it gives you an idea of what it is that I am mentioning or talking about. So seeing that comparison on the same graph or grid will help you to be able to sort of get a sense of the impact of the coefficient in front of your equation. Okay, so I hope that that helps for the first part here. Getting some examples with actual numbers or values can help to bring clarity to that. So moving on to the next one, we have our horizontal compression and horizontal expansion. So this is a little bit different. Well, we just finished talking about the vertical part and how that impacts your equation. And now you're going to see the same thing, but in terms of horizontal and where that's going to impact your equation. So notice your original function y equals f of x instead becomes y equals f of a of x. So again, there's that question, like notice that the a value is right beside the x, so you know that it's affecting your x values, which makes sense because it's a horizontal compression. If a is greater than 1, then it's by a factor of a half. So remember, when dealing with the x values, it's always the opposite of what you see. I'll explain that further with examples because I get that that's probably a little confusing. If you look at the next one here, horizontal expansion, okay, if I have y equals f of 1 over ax, then the horizontal expansion is by a factor of a. So it's sort of the opposite of what you see anytime you're dealing with values that affect the x values. Okay, so the best way to clear this up is to show you some actual examples with numbers or values that we can make sense of. So if we have, for example, y equals f of 2x, well, I would start by saying, or asking you, does this 2 affect your x values or your y values? It's with the x, so you know it's x. So you know that it's going to be a horizontal. Now with x, it's the opposite of what you see. So if you see a 2 there, it's actually going to be a horizontal compression by a half. So it's the opposite of what you see. And it's going to be a horizontal expansion by the opposite of what you see. So this time it's going to be by 4 because you see a 1/4 embedded into the equation. Okay, so I have broken them down into the smaller little pieces so that you can understand and grasp each thing one concept at a time. And then we'll eventually put it all together. So all of these separate transformations we talked about, we eventually are leading to a point where it's all going to come together and you'll get to see how we do the whole thing all at once. So before we get to that, let's practice some of these. Write the equation for y equals root x with, so this is my abbreviation for with, a W with the line on top. You'll see that often in my notes. For A, let's do vertical expansion by a factor of 3. So I want you to think to yourself, vertical expansion by 3, is that going to affect your x values or your y values? Since it's vertical, it's the y values, which means you put it in front of the whole equation. So 3 root x. Okay, the next one says vertical compression by a half, and with vertical we always take it as we see it, so it's going to be 1/2 root x. Those ones, so often dealing with the y values is easier because the y is isolated, so you take the values exactly as you see them. It's with horizontal that we have to put a little more thought into this. If we have a horizontal expansion by a factor of 3, well, what that means is we are going to put 3 or some version of that with the x values. So I can draw my root sign, and I need to think to myself, if I see a 3 written there, and I know that with x I always do the opposite, then it can't be a 3. I know I've got to put a 1/3 under there. And I do the same thing, or I guess the opposite of that, when I get to this next one. I know that x is under there, but if I'm seeing a horizontal compression by 1/5, then I know that I must have a 5 in here, because it's always the opposite of what we see or what we're working with. That would be a good place to pause, just to have a look and to make sure that you have it clear in your mind, the fact that the y values, you take them as you see them, and with the x values, you're doing the opposite of what you see there. So use that to sort of help you to get some clarity as we're moving to the point where we're going to mix them all up and put them all together. Such as this next example. What transformations took place to produce y equals -2 f of 1/3x if the original equation was y equals f of x? This is my abbreviation for equation. You will see that often in my notes. If you haven't had me as a teacher before, just so that it's clear, that's what's going on there. Instead of writing equation over and over again, I'll just abbreviate it like that. And so we're sort of working backwards, or we're thinking, if this original equation was this, what must have happened in order to produce this equation? So it's a good idea to break it down in steps, just like I did with the last part. So let's start with that step first. If we have a -2 there, well, we know that this 2 is affecting all of the y values. So I know that it's a vertical, it's a 2, so I know it's an expansion by 2. Okay, so there's part of it. Let's do it in order, like SRT. So let's do the S part here. So stretches. Notice how here I have a 1/3, and that's going to affect my x values. But it's always the opposite of what I see. So I know it's horizontal because it's with the x values. And if I see a third, I know it's actually doing this by a factor of 3. So if it's doing that by a factor of 3, I know it must be horizontal expansion. Okay, now let's look at the r part of it. I notice that there's a negative sign in front of the y values. So I think to myself, is this being reflected in the y-axis or over the x-axis? If it's taking my original y values and flipping them down, it's going to be a reflection in the x-axis because it's taking my positive y values and flipping them down. That's how I know that. And then there is no plus anything at the end or minus anything, so there's no translation. So I'm just going to put an x there, or I guess maybe over top, because that's all there is. Okay, on to the next one. If the point 2, 3 is on y equals f of x, what point is on this transformed equation? Oh, this is good. This gets you to really make sense of what is happening here. So a good approach with this is to break it down again. So I'm going to look at my x values, and out of here I'm going to pick out what affects my x values. And it's really just that. And then I'm going to say, if this is my y value, what out of here is affecting my y values? And it's going to be this, and it's going to be this. So I'm going to show you an approach that I think is really helpful, that I use as a strategy, and I teach this to all of my classes. It's up to you. If you find it helpful, go for it, and if you don't, you are welcome to use any other method that you do find useful. I'm going to treat the original point as xy, and I'm going to look at what it becomes. So let me explain. I am basically writing on here what I am doing to each of the values. So if this was x, after applying all the stuff here, I would multiply my x by negative, maybe I'm going to multiply it in color, negative 1 over 4 times the x that was there. And then for the y part, y would become 2y because of this. So 2y, oh, I'm going to do the y in the original black. And then plus 3 because of the thing at the end. So this basically tells us what I would do to the points. I find that this makes it much easier to make sense of. So if I had the point 2, 3 from above there, and this is the hardest part of my teaching, is keeping the colors straight. If I had that, and then I need to apply this to the 2. So I would do negative 1/4 times 2. So when I do negative 1/4 times 2, I actually get negative 1/2 is my new x value. And I want to do the same thing with the 3. I want to plug it in. So 3 times 2 is 6, plus 3. So I would get 9 for my new y value. This would be my answer. I feel like circling that didn't really help. Maybe like that is better. So to break it down into steps, what I did is step number 1, wrote out the point as xy. Then I look at what it becomes when I apply all the transformations. So to clarify that, it's what I am actually doing to the original point to get to my end result. And I got that information from these transformations. So I hope that that clears things up, but that's all of the transformation stuff split up over 2 videos. Here's the second portion of suggested work. You decide how much you're going to do. I have suggested all of them because I think a lot of practice with this is going to help solidify these concepts. But you choose if you've really gotten the hang of it or you've previewed it before, whatever the deal is. If you want to do odd letters or something, that's up to you. But this is what I would suggest. And that's the end of this video.